This is AP Statistics, Chapter 2, Test Review. The height of adult women are approximately normally distributed about a mean of 65 and a standard deviation of 2 inches. Sally is the 80th percentile in height for adult women. What is her height to the nearest inch? Now, if Sally is in the 80th percentile, that means 80% of the women have heights that are less than her. So the area on the graph to the left of her height would be 0.8000. So if you go to your table and you try to find an area of 80%, the closest on the table you can find is an area of 0.7995. And the z value that corresponds to that is 0.84. Now we know that z is equal to x minus mu over sigma. We know our z value is 0.84. We don't know her height, but we do know the mean is 65 and the standard deviation is 2. To get the x by itself, we are going to multiply both sides by 2, so those will cancel, and we'll be left with 1.68 is equal to x minus 65. To get the x by itself, you are then going to add the 65 to both sides, and we're going to get x is approximately 66.68 inches. Now the question tells us we need to round to the nearest inch. So we can say Sally is approximately 67 inches tall, which is in the 80th percentile. Give an estimate of the standard deviation of the distribution shown in the figure. Remember, when you are looking for the standard deviation, you're going to look where your graph changes from curving down to where it starts curving up. And where that changes is one standard deviation away from the mean. Since our mean is 0 and we are 30 units away where it changes curvature, then we can approximate our standard deviation to be 30. Mr. Pryor's AP Statistics class just took their first test of the year. Norman was told his z-score compared to the rest of the class was negative 1.32. Explain to Norman what this means. Norman scored below the class average on the test. His score fell 1.32 standard deviations below the mean. The day after receiving her statistics test results, so she took a statistics test, and she got an 86. Jenny earned an 82 in Mr. Goldstone's chemistry test. At first, she was disappointed. Then Mr. Goldstone told the class that the distribution of the scores were fairly symmetric, with a mean score of 76 and a standard deviation of 4. In Mr. Pryor's class, the mean was 80 and the standard deviation was 6.7. On which test did Jenny perform better relative to the class? To determine this, we are going to need to find the z-score for both. We need to standardize these scores so we can compare them. So on the stats test, our x value is 86, our mean is 80, and our standard deviation is 6.07. And that's going to give us a z-score of 0.988. On the chemistry test, our x value is 82, our mean is 76, and our standard deviation is 4, and that's going to give us a z value of 1.5. So relative to the rest of the class, Jenny actually did better on her chemistry test than she did on the statistics test. The normal distribution of weights of pumpkins in Mr. Brown's pumpkin patch follow approximately a normal distribution. Based on a large sample, it is found that 10% of the pumpkins weigh less than 6.31 and 27% of the pumpkins weigh more than 10.28. We need to find the mean and standard deviation of pumpkins in the pumpkin patch. So the first thing we need to do is we need to find this as an area. Remember, the areas are talking about less than the value. So on this one, we have an area of 0.1000. If we look at your table, we know that we're not going to find 0.1000 exactly on the table, but we can find one that is the closest, and that is going to be a z value of negative 1.28. Now, this is talking about on the other side greater than 27%. If we want to look at less than, we need to subtract that from 1 or 100. So we need to look for an area of 0.7300 on your table. And the closest we can find is going to be a z-score that corresponds at 0.61. Now, remember, z is equal to x minus mu all over sigma. So we're going to set that up on both sides. We know our z value is negative 1.28. We know our x value, but we don't know our mu or our sigma. Over here, we know our z value. We know our x value. But again, we don't know mu or sigma. For both sides, we need to try to get one of the variables by itself. So first, we can multiply everything by sigma. So this is going to give me negative 1.28 sigma is equal to 6.31 minus mu. Over here, this is going to give me 0.61 sigma is equal to 10.28 minus mu. Again, we want to get one of the variables by itself, so we can add mu to both sides. So over here, we're going to have mu minus 1.28 sigma is equal to 6.31. On the other side, we're going to have mu plus 0.61 sigma is equal to 10.28. To get the mu by itself, over here we're going to add 1.28 sigma. Over here we're going to subtract 0.61 sigma. So our two equations that we're going to end up with are mu is equal to 6.31 plus 1.28 sigma, and mu is equal to 10.28 minus 0.61 sigma. Now, since we have mu by itself in both of these equations, we know our equation on the left has to equal the equation on the right because mu is equal to mu. So now we're going to solve for sigma. To do this, we're going to add 0.61 sigma to both sides. We are going to subtract the 6.31 Then we are going to divide both sides by that 1.89. And that's going to leave us with sigma equal to 2.09. Now we just need to take that sigma and we need to substitute it back into one of the original problems, one of these two equations that we just solved to find our mu. So I can do 6.31 plus 1.28 times 2.09. And that's going to give me that our mean, or our mu, is approximately 9. So the pumpkins in the pumpkin patch have a mean weight of 9 pounds and a standard deviation of 2.09 pounds. The travel time for students from home to school on the bus is normally distributed with a mean of 35 and a standard deviation of 7. If a student gets on the bus at 6:45 a.m., what's the probability that the student will arrive later than the tardy bell at 7:30? Well, from 6:45 to 7:30 is 45 minutes. So if the student were tardy, it would take them more than 45 minutes to get to school. So first thing we need to do is find our z value. So we have 45 minus 35 all over 7. And that's going to give us a z-score of 1.43. Now, if we find the area to the left of 1.43, because remember, on the table, it's always going to tell you the area to the left or the probability less than, we're going to get 0.9236. But we want to find greater than, which is area to the right. To do that, remember the whole area underneath is 1, so we would subtract 1 minus 0.9236, and you would get 0.0764. So we can say approximately 7.6% of the time the student would be tardy. Graph an example of a distribution in which the mean would be smaller than the median. Now remember, if a graph is roughly symmetric, the mean and the median would both be located in the middle. If a graph is skewed to the left or skewed to the right, that graph is going to pull the mean in one direction. The mean is always going to be pulled in the direction of the longer tail. So if we have our median here, our mean, if it's pulled to the tail, would be farther to the left if the graph is skewed to the left, which would mean that the mean is smaller than the median. The weight of a normal Labrador Retriever is approximately normal, with a mean weight of 72.5 pounds and a standard deviation of 2.5 pounds. For a female Labrador Retriever, the weights are approximately normal, with a mean of 62.5 and a standard deviation of 2 pounds. Approximately what would be the weight of a female Labrador Retriever with the same standard deviation or standardized score as a male Labrador Retriever who weighs 78 pounds? So we know our male Labrador Retriever is 78 pounds. The first thing we need to do is find our z value. Remember, it's x minus mu over sigma. So we can do 78 minus 72.5 all over 2.5. Or we're going to have a z value of 2.2. Now it tells us that the female has the same standardized score, or z-score, as the male. So we know that the female dog also has a z-score of 2.2. So we can say 2.2 is equal to x minus 62.5 all over 2. To get the x by itself, we're going to multiply both sides by 2. And we're going to get 4.4 is equal to x minus 62.5. To get the x by itself, we're going to add 62.5 to both sides. And it's going to give me x is 66.9 pounds. So we would estimate if the male and female dogs had both the same standardized score, that their weight of the female would be 66.9 pounds. The graph displays the cumulative relative frequency of the length of phone calls made from the math department office at the high school last month. About what percent of calls last between 15 and 20 minutes? So if we go to 15 minutes, we can go up, take it over, and we know about 40% of the calls last less than 15 minutes. If we go to 20 minutes, again, you would go straight up until you hit the graph. Then you would go over horizontally, and we can see that 60% of the calls lasted less than 20 minutes. So to find the difference between them, to find out what happens between 15 and 20 minutes, we would just need to subtract the two. So 60% minus 40% leaves me with about 20% of the calls lasting between 15 and 20 minutes. The length of dog pregnancies varies according to a normal distribution, with a mean of 63 days and a standard deviation of 2.5 days. What percent of pregnancies last between 60 and 65 days? Follow the 4-step process. So since we have to follow the 4-step process, we do need to start with our state. So when we state, we can let x equal the number of days a dog pregnancy lasts, and we need to find the percent of pregnancies that last between 60 and 65 days. To make your plan, you need to draw yourself a normal curve. We know that we have 63. If we add to get above this, one standard deviation above would be 65.5. One standard deviation below would be 60.5. So we're going to be a little bit more than one standard deviation below. And we're going to be a little less than one standard deviation above. And we would shade the part that is in between. For the do part, we would actually do the calculations. So we're going to look when x is 65 and when x is 60, we are going to find the z-score. Remember, it's x minus mu over sigma and x minus mu over sigma. So a z-score when x is equal to 65 would be 0.80, which makes sense because we said it's a little less than one standard deviation above. And for the z-value for 60, we would have 1.20. Again, we said it's a little less than one standard deviation, so this should make sense. We're going to need to find the area to the left for both of these. So the area from here all the way to the left would be 0.7881, and the area from here all the way to the left would be 0.1151. Remember, you find these from your normal distribution table. So to find the area between, we would just need to subtract. And that's going to leave us with 0.673, or on our conclusion, we can conclude that about 67.3% of dog pregnancies last between 60 and 65 days.